Okay, so welcome everybody to this iNEMI roadmap webinar, where we will be covering the PCB topic inside the iNEMI roadmap. So Tarja, if you can bring us on to the next slide, please. So essentially, we're going to review that content that we have already published in underneath the PCB topic. For that, Tarja is going to take the lead. She is one of the two co-chairs for this work. She's a director with EIPC. The other co-chair is Joe Beers, who will chime in as appropriate. And he's from Gold Circuits, a VP from Gold Circuits. We'll spend about 40 minutes or so reviewing the existing content. I would suggest if you have any questions, please feel free to put them into the chat. Hopefully we'll have a few minutes to spare towards the end of that part of the session to address any comments, queries or suggestions that you make in the chat. For the last 20 minutes or so, we will do a little bit of an exercise, a little bit of brainstorming, more on future directions for the iNEMI roadmap in this space. And Joe will be leading the discussion there. The link for that brainstorming will be placed in chat. So please keep an eye out for that later on. But we'll come back to that on the mechanics of that later on. And that'll be for about the last 20 minutes of this session or so. So other than that, I'd like to welcome Tarja and hand over the session to her. So Tarja, the floor is yours.
Thank you, Frank, and welcome also from my side to this webinar. And I will try to be quick enough to review the content. And there was some links which unfortunately now doesn't work with my computer, so I cannot show this later on. But it makes you to visit to our web page to see this. So first, there is some technology scope of the roadmap and the structure, how the levels of electronics are in system level. And you can see that it starts from the level 0, from the semiconductor die, going to the component level, which is 1, and module level 2, and then there is the level 3. In parallel, the cross-cutting challenges like sustainability and smart manufacturing impact in every stage of the value chain. And this is, in this presentation I'm doing now, we will focus on the PCB level topics. And in all of these levels from not from the 0, but going up from the level 1 to 3, the PCBs are more or less included. And I would also like to take this opportunity to introduce and thank all the key contributors for the development of this roadmap. In addition to the core team, which you can see in this slide, many thanks also for all of those who has shared the valuable input, comments and feedback throughout the process. As a part of this webinar, we welcome and encourage further insight and perspective from all of you. Your engagement is valuable for making this roadmap as impactful and relevant as possible. So please feel free to be active in the end of this presentation. This slide is a little bit busy, but it illustrates the comprehensive range of benefits that a technology roadmap can deliver. It's not just a planning document, it's a strategic tool. And it's aligning the innovation with business goals. The roadmap helps focus efforts where they matter most. It's important. It supports data-informed decision making and ensure that resources, time, talent, and budget are used effectively. Most importantly, it strengthens the stakeholders' engagement by showing a shared, structured vision of where we are headed. So, creating the technology roadmap, it's just about planning for the future. it's about actively shaping it together. And here I want to show, because sometimes we are mixing what are design rules, what are capabilities, and what are roadmaps. So capability, it's normally handled in the factory level. These are the ones that the factories can do. Each of the PCB plants are different. They can have different capabilities. And design rules are those which we offer for the designers to make their design. And there can be some capabilities which are over the factory capability, but they can still make the product. And the roadmap is, of course, for the future of what is needed, what are the development tasks, and normally it's from 3 to 10 years ahead in things. And this is the content of the PCB roadmap. Here you see in the dark blue are those ones which are already published. A little bit lighter blue is the one that is ready for after review. We can release that one. The content creation we at this moment don't have in PCB roadmap, but the team formation level is on optoelectronics for the PCB. And as we all know, so actually the application requirements are driving PCBs. And today everybody cannot avoid hearing the AI and data center and what is coming on. And there the speed is amazing, how quickly you can get all the information. And that's really driving also the material. Here the M8 and M6 are the Panasonic materials, but there are other materials available as well, but it was just a very short, and everybody knows what that means. And also the low latency and high bandwidth for data transferring is essential. And what it requires from the PCB level is that more layers and even more HDI layers, and also much more controlled processes. And even for the hybrid PCBs where the optical interconnections are embedded or connected. And we cannot, of course, forget the good thermal conductivity. It's as a bonus, or maybe we think that it's not a bonus, but it's an essential. And nowadays also recyclability and eco-friendly hardware is needed because of the sustainability requirements, and also the cooling system, because there is a lot of heat created. So how to make it in sustainable way it's essential. And if we look overall the industry drivers, and as said, so the end device is driving our industry. Normally in PCB level, we see finer feature sizes, microfiers, thinner materials. Then of course, everything must be faster, higher throughputs, higher frequencies, and greater bandwidth. Then all these creates heat, which we have to get rid of the electrical equipments and all these. And also in PCB level, we see that higher operating temperatures will require more reliable materials in these temperatures. And then are the environmental things, how the factory operating can make smaller ecological footprint. And last but not the least is that all these must still be done in lower cost, so that should be calculated as functionality and performance, not necessarily by the square meters, because of the complexity of the board. So it's really the PCB features which are driving the complexity. Then we go for the first part of the roadmap content, which was released already in Q4 23, is the high speed. And if we look what is driving for the high speed, so it's actually all these which was shown earlier. So higher speed, higher data rates, and higher frequencies are needed. So nearly doubles every 3 years. So it's affecting for the PCB a lot. So we need higher layer count, more layers every year, and even finer feature sizes with these. So challenges up to coming. And then, of course, the component sizes are coming smaller. It's also depending on what type of application we are talking of. So for example, for line cards, they are doing 0.6. And then, of course, also the line and space sizes are different. But for the smartphones in motherboard level, it's 0.35. And then we see that they are coming thinner, and then also, sorry, now I was talking wrongly. This is thinner materials, not the pitch size that we were showing here. And what does that actually then mean in the board level? So today we have seen up to 60 layer boards where impedance tolerance is 8. And then if we look, so the tighter impedance tolerance and all tolerances are necessity in coming next 3 to 5 years, with thinner traces and more controlled traces combined with controlled, very good quality holes. And then the backplane functionality moves from passive to active, so we will see more active role for the PCB. And here are some of the solutions. So the red here means that the technical readiness level is from 1 to 4. If you see the yellow, it means that the technology level is from 5 to 7. And in green, it's the deployment level, where it's seen from 8 to 9. And this is the table which you can now find also in our iNEMI webpage, and you can click. Unfortunately, I can click it, but it didn't come to your screen. I see it only on my side. So this is only one very small part of the. These are the layer count and frequency drivers, which you can see now here. And then we come over for the substrate side of the roadmap. So that is IC substrate and Ultra HDI, and drivers there are the more layer count and more complexity in the PCB level. More layers and increased thickness as well, what is coming on. And then all these finer feature sizes and more reliable needs also new processes. So we have to look for the SAP type of process or MSAP. And one very important is the cleanliness, because if you want to make small feature sizes, the clean room is a must. And of course, then also the automation, because we as a human being, if we go inside the clean room, we bring particles. So the avoiding people touching the board, it's good. So investment for automation is needed. Oops, sorry. Sorry for that. And then fully additive process is seen, but there are still some development needed because before we can go for that one, but that would be from the environmental point of view and also from the feature science point of view, very, very good to make this research. And of course, the investment for automation and clean room is needed, and robotics. So there also the smart manufacturing will come on the picture as well. And from the material side, we see requirements on the copper. So copper must be very smooth, very nice kind of the shape in order to have good edge rate and capability for fine feature sizes. And if you look here, so the different level of the main board for the substrate or for the interposers. So there are different line and space requirements. So also the different level of requirements will come earlier. So in the substrate side, already they need the very kind of smooth and nice copper foils, and also some other solutions in order to go for even finer feature sizes. And if we look, so all the line and space requirements are coming from up to downwards, and also the technologies used normally come so that the main board manufacturers are looking how the substrate are done, and substrate makers are looking for how the interposers are done. So we can learn from each other very nicely. And here are some of the tables for the solution, and you can find what is our team evaluation on what is the technology readiness. And there, if you see something that, okay, you don't agree, or you have some other solutions which we might be missing in this table, these are more than welcome to be commented from your side. Then is the test, inspect, and measurement roadmap. So everything must be electrically tested, and it must be the 100% continuity testing with impedance and or the conductors, shape, and everything. And that is something where we see that the automation and factory AI can help, so that we can get all out of the electrical testing, and we get that back the information for the manufacturing, so that we know where are the weaknesses, what we need to develop further, where are the most improvements needed. And then, of course, one is also that how the traceability is done. So it's already asked that could it be so that every board, individual board, could have a traceability code inside, and that is very important in that level, that we can ensure the quality of the product, and it can be traced even when it's already out from the factory. And if there are some reasons that you have to make the callback, it can be done. But then there is still studies that it creates quite big place from the board, and can you have it, and how it can be read it, so that from the inner layers up to the outer layers, each board can be identified which processes it has gone through. So there are some nice development work still needed. And these are the technology readiness levels, which you can see here. And here, if you look for the improved multi-layer variation and optimized process, that is still in red. So, and also the AI machine control and handling, so which might help also for the traceability and also the using the information back in the manufacturing after testing. So where are the weaknesses and improvement places in our manufacturing? And environmental roadmap side. So then is how before we can know where we are, we have to know what are the tools available, what are the regional drivers or requirements, because it can be so that different drivers are in Europe or in US or in Asia. So that is really needed. And then how we manage.
I sent about over a week
Oh.
ago several different items, and I haven't.
Sorry. Now there is somebody on the line. And limited corporate. That what are the resources used, and how all of the industries working together. So we have to find the tools, find the platforms, and look what are the regulations needed in order to go forward. And really it's needs for the IT tools, and it's it was 2 times. And then is the energy. Of course, as said already, so AI data centers are requiring more energy, more cooling. So we have to look how the energy usage in manufacturing can be reduced, and what new technologies we can implement in order to reduce the energy used in manufacturing, and what are the alternative environmental friendly energy sources. And then, of course, in the PCB factory, we know that the what's happening? Sorry. So the water is one essential in PCB manufacturing. So we have to look how to make the recycling as efficient as possible and still environmental friendly, and not using too much of energy in that way, and reuse inside the factory, and then also recycle, so that all the water we let out from the factory will be clean. And here are the solution table, which is quite nicely, okay, it's yellow, but quite nearby the green already. And for the laminate side, so drivers for that one comes, which is mentioned already earlier. So as the bit size is coming smaller, so we need to have the smaller, thinner core and thinner build-up layers. And that ultimately will lead, because everything will be very nearby each other. So it creates a risk for the reliability. So CTE must be in all level nearby each other. Maybe looking so that if it can be nearby the copper, it will be, or even in silicon, depends on what kind of products we are talking on. So that's good, because when the operating temperatures goes up, also the CTE mismatch will create more headaches, and it's essential to have to ensure the long-term reliability. And then is the speed, and which requires lower DF values. And in order to fulfill these DF values, we have to have new materials. And these material properties must be taken in account when we are planning how to process the boards, because some of the materials might require some adjusted parameters for the drilling, for the multi-layer pressing, or even for the plating. So this must be found in the place. And then is also, the more homogeneous is the material, the easier it is for the PCB manufacturing to handle. And here are the laminate solutions table. So this is only example from the build-up process for miniaturization, and which are the things and solutions we have found. And then is the microwave roadmap, and that is driving by the frequency rate, and it's in automotive is the ADAS, which is the driver, and in telecom side the wireless systems. And there is also the low loss materials needed in order to fulfill these requirements. And same is also copper foil, smooth and nice copper foils. So as you see, the same drivers and same solutions or same requirements are coming on the different application needs. And then is the thermal management, which has already been few years kind of the hot topic in hot discussions. And to find out the solutions for these higher operating temperatures is essential. And there are coins, there are materials, and even some dielectric materials which can solve. But if you cannot solve it with the material selection, you have to use the coin or some metal cores inside your PCB. So these hotspots are important to overcome and look from the material side. And then is the microwave solution table, and there is the one which is still very in research level for the circuits is really the 3D printed structures inside that you could print metal inside the PCB. So that would be nice environmental friendly solution. So here is my conclusion and key takeaways from these roadmaps. So market-driven solutions align the innovations and industry needs together in order to find out the best solutions, and the drivers are AI, automotive, telecom, but as you have seen, they don't differ so much. They are only, of course, then you might need different manufacturing equipments if you have big boards or small boards. But in the end, they are very similar. And it's very important that we are all working together as a supply chain and have a strong collaboration between all stakeholders, so that we can focus on high reliable end products and also include the eco-friendly and recyclable solutions for the sustainability. So as a last comment, so innovation today will be the future of tomorrow's PCB. Thank you. I was a little bit quick.
Many thanks, Tarja. It gives us a few minutes if people have any questions or
and I'm sorry,
comments.
I noticed that some of my animation came 2 times. I don't know why, but seems to be it's not my day.
No, it's not a problem. So look, we have a few minutes, everybody. If you have any questions or comments, feel free to unmute yourself or to pop them into the chat. We can take a couple of minutes if there's anything that is burning on your mind at this point in time. Should it be the case that you have thoughts afterwards, we also welcome input at any point in time. Feel free to reach out to myself or Tarja or to Joe for any suggestions or comments. But anyway, is there anybody who wants to have a comment? I see I have a query here. Yes, regarding your query regarding the copies of the slides, we will be distributing the slides, and we will be distributing a link to we will also be distributing a link to the recording as well. Lenora, you were trying to get in, or you have a comment to make?
Hi, Tarja. Lenora Clark from McDermott Alpha.
Hi, Lenora.
How you doing? Just wanted to ask about the thermal management slide. Obviously, just like you said, hot topic in the industry right now. We get a lot of requests for significantly high thermal management from the package. And I was wondering if you thought those numbers specific to the PCB were going to change, or if you think they're conservative.
I think these were more for the laminate, these values, which you could see there. So I think I know that those who are doing the kind of the coins or metal core PCBs, so they are having higher values.
Okay, thank you for the clarification.
And I think you have also been involved in making the paste type of, which would be for the PCB manufacturer very good, because you know that embedding the coins has some headaches also.
Yeah, not so easy.
Not so easy. Yes.
Yeah, thank you.
Thank you.
Okay, we have a few questions coming in on the chat, and I see Amba as well wants to ask a question, but let's deal with some of the questions here on chat first. William Beckenbaugh asks, please comment on Flex Circuit roadmap contents and directions.
Sorry, we didn't have the Flex in this one.
Yeah, so this
is the different. It was not included in this presentation.
Indeed, and that's a question we need to address. Do we launch an initiative to redo that roadmap there for that? We've done a bit of work on that in the past in the iNEMI roadmap, and it's certainly an open question as to whether or not we should come back to that topic again.
Yes, that's right. That's right. I think because that was not, yeah.
Sorry, Tarja, go on.
Yeah, it's okay. It's okay.
Yeah, okay. So John Ballange, what percentage of these new PCBs will be in mass production by 2028 and onwards?
You mean which kind of, because there are actually multiple type of PCBs. So if you think for the high layer count, or you mean the Ultra HDI, or
let's try the Ultra HDI. Let's take that one as a case, as an example, and address that one.
So Ultra HDI, I think we put in the presentation. Let's look what we had there. That is now the pity that I cannot show you the whole solution table, because there would have been some. So if we look here, there are if we think that SAP process, so I think in some substrate side, they are already using the SAP with the Ajinomoto material, but that is limited. The challenge in SAP, or if this is semi-additive or full additive, this is also which we think that the fully additive process, if you use that one, you need a specific dielectric in order to have the good adhesion. There are now some solutions coming on, which I have heard that maybe some primers or whatever you can use in order to increase the adhesion between the copper and the dielectric. But I think the modified SAP is already in mass production, if we think that one. But of course, then in which level we are talking on, when we are talking on substrate and Ultra HDI, they are prepared already for making the improvements and putting the thinner materials and smooth copper, because they have to do it in order to fulfill the requirements.
Thanks, Tarja. So, Joe, from your side, would you have any thoughts on how fast we transition through to mass production here? What would be your
I really
take
do
on it?
think, yeah, I do think the network and the servers are starting to merge. Everything's the network. So as you follow the need for 4 times more data, which you see, merging 800G and 1.6T, that's going to be around, that's going to increase the percentage of adoption. Right now, I would say the percentage is pretty small for some of these high layer count boards, but with some of the massive, with some of the massive rollout of data center and next generation products, that percentage will increase by 2028 significantly. So I'm gonna, I don't have an exact number. Obviously, that's part of that is a large ecosystem of investment, but based on investment now, the percentage will be significant. And what I mean by significant is in the 15-20% or more, I think. So.
Okay.
Yeah. And I agree, Joe, in that sense that it depends on also the application and what on the factory and where they are focusing on, because the investments are in some phase quite huge. So you cannot focus on multiple new product applications.
Okay. Another question here from Ranjan Raju. Any comments on the use of glass core for IC substrates?
Good question. I think that is one quite much discussed already, and it has really the benefits. And actually, the glass core has been already used for some optoelectronic applications, and I think for the substrate, it will be coming on, and there are some studies going on. The one I have heard, the latest information was so that maybe some type of volume production could be after 2 years, 27, 28, but there are studies ongoing. And there is also the challenge for the adhesion and all this, and of course the handling of the core, glass core. But that is maybe too early to say that when it really will be. But now it looks like that at least there are activity ongoing.
Okay, thanks. There's a question about whether there's any research paper or work in progress from iNEMI in the area of biodegradable PCB materials. I'm going to leave that one to some of my colleagues who are actually online at the moment, if they have any comments on that one from the project side, because honestly, I'm not sure what the answer is offhand on that one. So, if Grace or somebody else would like to comment there, it would be good in the email, in the chat.
Yeah, we don't have, if I could, Frank, we don't have any active projects in the area, but we actually will have a presentation looking at some of the advances in materials for biodegradable printed circuit boards coming up. I think it's later this month. I'll put the details in the chat. I think it's up on our calendar of events on the website. Okay. Or if not, you can keep an eye out, and there will be a presentation on exactly that topic. Okay.
Yeah, it's also something we're discussing as well. It was one of the ideas that came out of the roadshow workshop that we did at EIPC Apex. So that is on our TIG radar as part of the PCB group as well. So I imagine there will be some new things coming out.
Okay, thanks, Grace. Thanks, Emma. Does the emergence of AI computing require its own unique development roadmap? And so, Joe, Tarja, I'd like you to comment on that from a PCB perspective, PCB roadmap perspective.
I'll say on two elements. We did on the high speed section, it kind of implies that AI server and the emergence of AI is making much greater demands on the amount of data that needs to move through the system, as well as any implications on circuit board design. Also on the test and inspect, we kind of mentioned how the AI factory is important to keep pace. So in order to make more complex boards, you need AI to help you on your actual factory design and recording and measuring and feedback loop. But I do like the question personally, because it could even be its own topic potentially, as AI designs, you know, as the element of AI being the driving design and manufacturing is growing so fast.
Yeah, and I think I totally agree. And I also think that maybe there will be some other devices which are connected to AI system with some new, totally new kind of features or sensors or whatever. So to have that as an own roadmap topic might be good.